Hello, I'm Maximilian, and I'm going to be presenting on dynamic programming as my topic. It's a pretty broad topic, but I'm just going to kind of dive into the basics of it for this 5-minute video. And it's really because a lot of people think it's complicated, but it's not quite as daunting as it seems. So to learn it, let's start with something we're more familiar with, right? Recursion. Uh, Recursion, quick review, it's just when a function calls itself in its function body, right? So for example, here, when we're this multiply function, it will decrement one input and add the other. So multiply 2, 2 calls multiply 1, 2, which calls multiply 0, 2. And when you come back up the recursive call chain and add up all the results, we get the answer to our original problem. Now, why this is useful is actually used in problems known as divide and conquer problems, where essentially you have a given input. This is for merge sort, which maybe you're familiar with. And you basically say, okay, to solve this input, I will split it into smaller inputs and then run those inputs with the same algorithm. And then you can use the results of those inputs to then generate an output for the larger problem as a whole. And so this is why the recursive algorithm is so effective in these cases. Now, these smaller problems are known as subproblems, and it's not always as simple as like a binary tree as it is for something like merge sort. Take this function here, just a Fibonacci calculator, right? We have some base cases here, and then we have this return value, which just sums up the previous two Fibonacci numbers. Now, if we plot out an example here, say we run for fib of 4, this will calculate fib of 3, or call for fib of 3, which will call for fib of 2, which will return 1 and 0, and then add those up, and then this will also call 1 and add that up, and yada, yada, yada. And what you'll notice is that, say I've calculated for fib of 3, right? And inherently, I've also already calculated what fib of 2 is, right? If I'm trying to calculate fib of 4, I want fib of 2 again, but I've already done the work for fib of 2, and yet this function will just call to get these again. It's going to do the work twice. So if I already know what fib of 2 is, would there perhaps be a way to kind of avoid that? To basically say, oh, I need fib of 2, but I already have it. I've already done this work, so can I just use what I have there instead? This is a process known as memoization of subproblems, right? It sounds a little weird, but basically just saving your progress, right? If you've solved a certain subproblem, record the answer for that subproblem. So if you have to solve for that problem again, you can just pull out the answer rather than redoing all of the work. This is the code, if you've implemented something like this. What you can see is that we calculate our Fibonacci total, but before returning it, we actually store it in a map of results. We can use maps, vectors, whatever. Basically, the important thing is that we're storing our total for that subproblem. And if we ever encounter that same subproblem again, we can just return what's stored. And then this would, drastically simplify things if this is how our map would look at the end of that recursive call. And basically, when we, run into the 2 here, what we can just do is we can just pull the 1 here and return that rather than having to do these calculations again. Now, all recursive functions are made up of base cases, which are these two statements here, and a recurrence relation, right? We've been discussing top-down DP, whereas basically you start with your larger problem, you use your recurrence relation to work it into smaller problems, and then when the smaller problems eventually become base cases, we return something, and then kind of come back up and solve for the solution to the original problem. But there's actually a slightly more advanced way to do it, known as bottom-up DP, where we basically start at those base cases and work up to the overall problem solution. I think this will make a little bit more sense with an example. Say this Fibonacci program here, this one's bottom up. What we essentially do is we start with 0 and 1 already filled out, and then we say, oh, fib of 2 is just going to be the sum of these two values. Fib of 3 is just the sum of these two, so on and so forth, until we get to fib of 6, and we've already calculated fib of 4 and 5, and we can just add these two to get our total solution.